Hi everyone, this is Chris and I'm a volunteer at the Hampstead branch of Pender County Public Library. Today we're going to be doing a fun water tension experiment. Make sure you have permission from your parent or guardian to do this and have adult supervision and help as needed. Okay, let's get started. First you'll need a few common household items. Here in front of me I have one large regular paperclip and one tiny paperclip. I also have a bowl of water. A cup of water will also work. Okay, so first, I want you to try and get this paperclip to float on the top of this water. I want you to try and make it float. You can use your hands, anything. Here we go. I'm going to try and place it gently. Try doing that. Maybe just try dropping it. As you can see, it's pretty hard to get this paperclip to float. And that's because of something we talked about a few weeks ago called density. This paperclip is more dense than water. So, naturally, the paperclip will sink. However, there is one way where we can use our other paperclip to make this paperclip float on the surface of the water. I'll show you. I want you to take your paperclip and bend it so to form this kind of almost T shape, like so. And then we're just going to place the tiny paperclip on this little T part, I guess, or this ledge here. And now we're going to gently place this into the water. Gently. I want you to try. This might take a couple tries, and that's okay. Here you go. Try again. Ready? Dip it in. And just slowly pull away. Whoa! That's crazy. Now this paperclip floats all of a sudden? What's going on? Well, we are using something called surface tension to accomplish this. So, if you think of water as very tiny, a lot of tiny molecules, which is what water is, it's multiple molecules held together by these connections, by these bonds. And so you notice this when you have a glass of water and it's almost about to overfill. If you look at it, you'll see there's a tiny hump or little bubble there. And that's because of the surface tension. The water's surface tension prevents it from breaking, and maybe in that case, the water overflowing. And in this case, this surface tension, the bonds between these molecules, instead of breaking and letting the paperclip sink, it's staying together. And this is because we laid this paperclip down gently. We made it so that it was able to rest on the surface tension. If you've ever seen a water strider in a pond, their legs, they're so light and their legs are specially made so that they can almost float on the water. But they're not actually floating, they're just using the surface tension. And one way you can tell is that when something floats, sometimes some parts of it sink, parts of it are underneath the water, while the rest of it's above water. And that's the difference between floating, whereas in this case, all of it's above the water because it's resting. It's resting on these bonds between these water molecules. And that's called surface tension. Thank you for joining today. I hope you have a great week and stay safe. I'll see you next week. And this experiment came from Science Experiments for Kids Love My Science. Thank you. Bye-bye.